parts of the atom. So we all got the notes in front of us? With me? All right, so yeah, everything is made of atoms. Atom, we would call it the smallest particle of an element. An element is a different kind of atom. So if you were to look up here, you have three main parts of the atom. The very center part of the atom is what we call the nucleus. So the nucleus has two main things, the proton and the neutron. The protons are going to have a positive charge. I remember that because proton starts with P, so P for positive. And then neutron, so proton, P for positive. Neutron is neutral, as in has no charge, so neutral. And then the third particle, it's outside the nucleus, is called the electron. And electrons are negative. I remember that because there's two E's and electrons, so electron negative, like that, kind of emphasizing that E sound. Okay? Any questions so far? Good with filling in the blanks? Okay, cool. So then, building upon that, let me get my cursor here. Oh, and another thing with these electrons, they are, you kind of see like, I don't know if you ever saw like Jimmy Neutron, but like these electrons are basically like flying around in these rings. They call them orbits. So these electrons will move around into these things called orbitals. We'll talk more about them and kind of some of their details later on in the class, but just kind of giving you that idea. All right, now then. If you look at this chart here, but the part of it is like the first two columns are a summary, like the location of the proton, nucleus, location of the neutron, also the nucleus, and then again that electron, it is orbiting the nucleus and those electron clouds. Now, the charge, as I said, the proton is positive. How you represent that is a +1. So if you had one proton, you'd have one positive charge. You have two protons, you'd have two positive charges. And then neutrons, they have no charge. And then electrons, they have the opposite charge of a proton. So if you had two protons and two electrons, their charge would cancel out. But let's say I had three protons. So we'll say 3p and two electrons. What would my charge be? Yeah, +1, right? You'd have a +1 charge. That's because each proton is a +1 charge. So if you have three of them, that'd be a +3 charge. Be +3. And then each electron is a minus charge, so that's why they're going to subtract from each other. Now then, another interesting thing with these particles is their mass. So the proton and the neutron, they each have a mass of approximately 1. Now, when I say 1, the units are what is called AMU. AMU stands for atomic mass units. AMU stands for atomic mass units. Okay. Basically, it's a very, very small unit of measurement. And then we'll talk about later on how it relates to grams. But just think 1 for now. If you have 5 protons, that would be giving you 5 AMU. If you had another 5 neutrons, that would be an extra 5. So you'd have 10 AMU. Now then, an electron, its mass is 1/2000. And it says here in parentheses, negligible. Negligible means like insignificant, really small. Basically, this means 0. When you think electron, think that its mass is essentially 0. So think of it this way. Let's say I have an atom, and that atom has 7 protons, 10 neutrons, and 7 electrons. And this is kind of like the symbols you'll see with a lot of that here. You'll see P for proton, N for neutron, and then electron you'll see like an E, And then because electrons are negative, you'll see like a little negative sign in the exponent. What would be the mass of this atom? If you had 7 protons, 10 neutrons, and 7 electrons, what would the mass be here? 17, yeah, good. You have 7 protons, each proton's a mass of 1. 10 neutrons, each neutron's a mass of 1. And then 7 electrons. But hey, electrons, we said their mass is basically 0. So you would just get 17. And 17 AMU, that would be your unit. Now let's say I have 9 electrons now for this atom. What would the mass be? 17 AM, yeah. Because again, the electrons don't have a mass, so it wouldn't change. What was that?
What if you have like 2,000?
That's a good question. So somebody asked, what if you had 2,000 electrons?
Then it would still be 17. Be 18, right?
Yeah. I guess you then add 1. The issue is you would never have. There's no such thing as an atom with 2,000 electrons. There's a limit to like the size of an atom, so it just can't happen. But that's I like the thinking there, because it says 1 2,000ths there. Okay, so that's kind of the basic idea you want to be able to do is kind of be able to add up, be able to find the mass of an atom and add up the mass of those different particles. Now this is one of my favorite slides that we'll do because there's something like really pretty fascinating and not obvious about atoms. 99.9% of the mass of the atom is in the nucleus. So the nucleus, we said that's where the protons and the neutrons are at. But here's the deal. 99.9% of the volume, like the space the atom takes up, is outside of the nucleus where the electrons are. Now what's the problem with that? Why is that just like kind of why should that kind of blow your mind? It's kind of like almost like a contradiction here. Yeah. Well, the protons would be part of the nucleus. When we say nucleus here, we're talking about the protons and the neutrons. So the protons would be included when we talk about the nucleus. Yeah. Yeah. Usually, like if you're like if I were like, hey, this person, this football player has a mass of 150 pounds. This other football player has a mass of 250 pounds. Most people would be like, I bet that football player that's a mass of 250, they would take up more volume. They would be a bigger person, right? That's kind of what you normally see. But this is the opposite. The protons and the neutrons, they're the things that actually give mass to the atom, but they take up essentially none of the space, none of the volume of the atom. And the electrons, the things that we said don't have mass, they take up the majority of the volume of the atom. And in fact, you could think of scaling-wise, if like the atom is a football stadium, the nucleus would be like a marble at the center of that stadium. And the electrons would be like everything else. Where the electrons, the space they take up, would be like the entire rest of the stadium. So in other words, like the consequence of this is, if all of life is made up of atoms, most of life is just empty space. I'm going to say that again. Everything's made of atoms. If only like, 0.1% of the volume of the atom has mass, and everything's made up of atoms, then that basically means that most of life is empty space. It's kind of wild. So then why don't you just why am I not falling to the floor right now? Like, how is it you're sitting in a chair, there's like any sort of structure in the world?
Because 99% of it.
Tell you?
99.9%
It'd be the other way around. It would be only 0.1% of it actually has mass to it, but you're not just falling through. In other words, 99.9%. That's all right. 99.9% of the volume is just of the universe, just like this empty space. Yeah.
There's a lot of the atoms and they're close together.
Yeah, all these atoms, they interact with each other and they form these things called bonds. And these bonds are what is preventing you from just like falling to the floor. And it's going to give a lot of these properties you see when you have these bigger materials. So anyways, I just think it's kind of neat and just sort of a little mind-blowing. But keeping it moving, we can talk about the mass number and the atomic number. So whenever you represent an element, you're going to use something called the element symbol. So the element symbol here is going to tell you what element you're working with. So for example here, if you see Li, this means you're working with the element lithium. Now, when you see that X over there, like on the left part of the slide, X is just saying, like in algebra class, X would represent any number. Here, X represents just any element you want it to be. An example would be lithium, but this could be any element that you see on the periodic table of elements. And then the number you see in this top corner here, so here where they represent it by A, that is your mass number. And then the one in the bottom left corner, that's what we call the atomic number. Now, the mass number, that's what that represents is the number of protons plus the number of neutrons. Now, that should make sense to you because I told you a couple slides ago that the things that give you mass in the atom are the protons and the neutrons. So if you look at lithium, for example, lithium has 3 protons and it has 4 neutrons. So its mass number is 7 because 3 plus 4 is 7. Now then the atomic number, that is the number of protons. So if you see a 3 right there for lithium, that means lithium has 3 protons. Now there's something else for the atomic number. The atomic number tells us the element. In other words, the element you're working with is determined by the number of protons. So if you had any atom with 3 protons is always lithium. If it has 4 protons, it would no longer be lithium. It would be the next element in the periodic table, which would be beryllium. If it has 5 protons, it would then be boron. Okay, making some sense? All right, let's do some practice with it. How many protons would be in a lithium atom? We just did lithium. Let me switch this up. How about a carbon atom? Let's do carbon. How many protons are in a carbon atom? So if you look up here, you got the big periodic table in the classroom. And at the desk, there's those laminated periodic tables. Take a look at the periodic table. Find carbon. It's this C right there. Okay, so let me raise your hand for me. Yeah, 6. 6. It is 6. Say it proudly. It is 6. So you'll see it shown a little bit differently depending on what periodic table you look at. On ours, it's the number in the top right-hand corner. So it's the blue number. So it says 6, 7, 8. So carbon would have 6 protons. Okay? And then the number underneath in red, and the number's got like the decimal points, that's going to be your mass number. So then mass number would be the mass number of neon. Neon has an atomic number of 10, so it's the end of the second row.
20.1797.
Love it. 20 point.
And then don't you round it up?
1797. Yeah, so it depends on, the honors, they worry about significant figures when you work with numbers like this. For us, we can just round, and that's fine. Some people will say round to the nearest whole number. For our purposes, to make the math a little simpler, I'm fine if you just say 20. I'll explain in a couple lessons why there is the decimals there. But yeah, but for now, just the number can change depending on how many decimal points you go to. All right, now let's say you have an atom, or excuse me, what atom would have a mass of 40? Not potassium. Raise your hand. Yeah, calcium would. with say calcium. If I say calcium has a mass number of 40, what issue is there with that? Yeah. That's true. It's technically not exactly 40, but that's not really what I'm getting at. Take a look at argon. What do you notice about argon? AR. Which, in other words, is basically 40. So in other words, calcium and argon, they each have a mass number of 40. Now, what did I say in the last slide about, like, why? In other words, what does this tell you about using the mass number? What it tells you is the mass number isn't going to tell you exactly what element you're working with. What do you have to look for to find what element you're working with? Anybody remember? What will always be true for, say, calcium? Calcium will always have what? Yes. Yeah, good. Calcium will always have 20 protons. In other words, the atomic number, that will always tell you what element you're working with. Okay? All right, now number 4. How many neutrons are in an oxygen atom with a mass number of 16? This one's a little trickier. Let me remind you, mass number, that equals the protons, P, plus the neutrons, N. So, okay, using that in mind, what will be our mass number?
8.
I'm sorry, or how many neutrons? Or how many neutrons? 8, yeah, exactly. Now, how you would do that is, you know the mass number is 16. So 16 equals. Now, I have a question. How did you get yourself to 8? Because, like,
Yeah.
P, how did you know the P? What's up? Yeah, you find oxygen. Oxygen will always have 8 protons. That's the key thing to understand there. The number of protons always stays. So as soon as I said oxygen, you know what P is, because if it's oxygen, oxygen always has 8 neutrons. And then 8 protons. Then we can solve for N by doing like your basic algebra. To get N by itself, minus 8 from both sides, and you would get 8 equals the number of neutrons. Okay. All right, now then, let's do the last one, number 5. The nitrogen atom has blank protons. What do we think? 7, yeah. Let's let's get the hands up. You know, that way it's not, yeah.
14.
Not 14. Neutrons. Any neutrons? 14 is the mass number. Yeah.
Read that wrong.
7. There you go. Yeah, somebody said 14. The 14, that would be the mass number. That'd be if you add the protons and the neutrons together. And then, so yeah, if you were absent or something, I do have the answers written on the next slide. So you keep that in mind. But I just kind of had this up here just, feel it's a little more engaging if I write on the board. Yeah.
So protons and neutrons are
Protons, you ask if they're the same?
Yeah.
That when you're talking about the mass, they contribute the same amount. They each give 1. But they're not the same because protons have a positive 1 charge, neutrons don't have a charge. So that's where they're going to differ.
So
Question? Yeah?
When you find the neutron, you just look at like the mass number and then you subtract the mass number by the amount of protons?
Exactly. Yeah. All right, let me stop the recording here.